Guided exercise number 4. Suppose the velocity of a particle at time t is given by v equals t squared minus 64 all over t plus 1, where t is greater than 0. Part A says determine when the particle is stationary. Now, I read over this quickly. Make sure you didn't miss it. This v represents the velocity. So you're not actually given the position function. You're given the velocity. So if you want to determine when the particle is stationary, that means you want to know when the velocity is equal to 0. So set the velocity equal to 0. 0 is equal to t squared minus 64 all over t plus 1. And the only way a fraction can work out to be 0 is if the numerator is 0. So 0 has to equal t squared minus 64. So 64 has to equal t squared, so t has to equal plus or minus 8. Now, in this situation, negative times don't count, so t has to be positive 8. And we don't have any units on this one, so t equals 8 is our best final answer. Part B says when is the particle moving in the positive direction and in the negative direction. So note, we only care about positive t. So when we look at all of the possible times, we're going to go from time 0 to time 8, and then from time 8 to forever. So time 8, because that's when the particle is stationary. And we're going to do the same thing that we've been doing, which is make a chart of plug something in, figure out the sign, S-I-G-N, of what you plugged in, and then use that to figure out the direction of motion. And so for the first column, I'm going to plug in 1. So V of 1 is negative 63 over 2, which is negative. So the direction of motion, it's the negative direction. And then for the next column, I'm going to plug in 9. You could make an argument that plugging in 10 is better. If you want to, go ahead. So V of 9, so I'm going to get 81 minus 64 all over 10. So I like the all over 10 part. And this works out to be 17 over 10. So I got a positive number, and the direction of motion is the positive direction. Part C says determine the acceleration at the instant when the velocity is 0. So if we're trying to determine an acceleration, we're going to have to work out the acceleration function. So we need to take the derivative of the velocity. So the acceleration is the derivative of the velocity. So low d high minus high d low all over low squared. Okay, so let's see. I'm going to have to do something with this, so I'm going to simplify it a little bit. Let's see. So 2t squared plus 2t, and then minus t squared plus 64. I distributed that minus. And then all over t plus 1 quantity squared. So the acceleration is t squared plus 2t plus 64 all over t plus 1 quantity squared. And we want the acceleration when the velocity is 0, and we already figured out that happens at t equals 8. So we want the acceleration at time 8, which is 8 squared plus 2 times 8 plus 64 all over 8 plus 1 quantity squared. And I would just leave it like that. We really, there's no real benefit to trying to simplify what you've got there. Part D says determine all values of t for which the acceleration is 0. So we have the acceleration, and we want to know when is it 0. So the acceleration is t squared plus 2t plus 64 all over t plus 1 quantity squared. And so the acceleration is going to be 0 when this numerator is 0. So 0 equals t squared plus 2t plus 64. And I don't see how to factor that immediately, so I would go ahead and just do the quadratic formula. So t is negative b plus or minus square root of b squared minus 4ac all over 2a. So negative 2 plus or minus square root of 2 squared minus 4 times 1 times 64 all over 2a. And this is problematic because what we have is negative 2 plus or minus square root of 4 minus 4 times 64 over 2 times 1. When we do 4 minus 4 times 64, we're going to get a negative under the square root. You can double check me with your calculator if you want to. You're going to get a domain error, and we have no real solutions. And so what that means is the acceleration is never 0.